It's
but not super in depth, you know.
yeah, it's the entire class you just set up. Every week you have two spreadsheets you set up, and it's at first it's like super easy, and then they get into like harder things, and it's like kind of annoying at the end, but then it's like so helpful. I use I like don't even have a calculator anymore because Excel is so much easier to use to have like everything and be able to view everything and every step. It's pretty cool. So, all right, well, let's get this going.
Yeah.
So number 6, what are the 3 assumptions need to be checked before you compute a confidence interval from the mean? Like the sample, know that it's a random sample.
Yeah, it needs to be a simple random sample, right?
Yeah, and the X bar is normally distributed, and then the standard deviation is assumed to be known.
Yeah, perfect. Okay, number 7. What is the point estimate for the population mean? That's just 541, right? Just where it says right there, the sample mean students 551. It's pretty rough.
Yeah.
Create a confidence interval for the population mean. Show all your work below.
So we got for the 95%. Did you guys round at all? I didn't round.
95%. If there was any rounding in the end, if there was any rounding at the end is when I rounded it, and I rounded up.
Okay. I didn't round at all. I just used what it gave me in the Excel document, and I got 532.1301 for the lower end of it.
Yeah.
And then 549.8699 for the higher end.
Yeah, that's what I got.
Cool. Yeah, 532.13 you said?
Yeah.
And then 549.869?
Yeah. If you're doing just rounding to the second decimal, it'd be 0.87.
Yeah. Okay, cool. Yeah. All right, and then
then change basically just the next question. You just change the sample size from 50 to 100, and I got 534.728 and 547.272.
Me too.
Bingo. That's what I got.
I like that. Yeah, this spreadsheet's sweet. Helps out a lot.
Yeah, it's helpful. All right, next one. We changed just the confidence level from 95 to 90, and we used the facts from question from the one before it with just 50 students. And excuse me. And for that, let me see, question 11, right?
Well, we still need to answer question 10.
Yeah.
Oh, let's get
one. Which is, how does the margin of error for 95% change from, or compared to changing the sample sizes?
And interval smaller.
Yeah,
the larger the sample size, the closer that margin of error is going to come to the actual.
The actual mean.
Yeah.
Yeah. So the higher the sample size gets, the smaller the margin of error becomes.
Yep. Sorry, I definitely skipped a question there. All right. Excuse me. For 11, I got 533.556 and 548.44.
Yeah, that's what I got.
Sorry, one more time.
533.556 and 548.444.
And that's for changing and we get that through changing the critical value, right?
Yeah.
Yeah, well, the confidence changed back to 90, and then
So, remember, I watched the video. I don't know if either of you guys watched the intro video or the help video. And it was like, literally, you could find the confidence value by finding the z-score of the center spot on the probability applet when you put in the decimal for the confidence interval. So if you go to the probability applet and then you put in 0.9 and you just highlight the center, the z-score is your critical value.
Oh, okay. All right, too easy.
Yeah. When I saw that, I'm like, oh, well, that's
Yeah.
I don't know why you don't just call it the z-score of the center, whatever.
Yeah. Critical value sounds a little better than the z-score of the center of your.
Yeah.
Yeah.
Center of your probability applet that may
Yeah.
not be available to everybody.
Yeah. Yeah. They thought of this. They thought of this in like the 1800s whenever they came up with this.
Yeah.
All right. So number 12. What happens to the confidence or the margin of error gets smaller than it, or is the sample smaller, it gets bigger? Or
Yeah. So as
thing.
as your confidence interval goes lower, your margin of error goes lower as well.
Yeah. And then 13 question is, BYOI student would like to repeat the experiment, but he wants to make sure he has enough students in the sample to ensure that his margin of error is 5. How do we do that? And it's just the same thing, except we just solve for the sample size rather than the whatever it's called.
Yeah. I got approximately 157 students. I don't know if that's what you guys got.
I did. I got. I did 158. It was at like 4.9.
This is what you definitely need to round up because you can't have 157.3 students or anything.
Yeah.
So you need to round up to 158.
Yeah.
Okay, 158. That's what I did wrong. I had it on down. Okay.
Okay, cool beans. So get this not group meeting, group quiz going. All right, so find the margin of error for a 90% confidence interval where the standard deviation is 50 and the sample size is 25.
Let's see. So,
don't we need to know the
no.
the mean for that, or does it? Oh no, we're just doing the margin of error.
Yeah.
So the margin of error is. Did you guys at 19.6? Oh, 3 decimal places. So yeah, 19.6.
1.6. So wait.
Why don't we need a point? What's our point estimate number for this?
Well, for the margin of error, you don't need the point estimate. You just need like the z-score, which for the 95 or the 90%.
Okay, so I got 16.45. Yeah, 0.45.
So N was 25. The standard deviation is 50.
Oh, you know what? I did the z-score for 95, not 90.
So I got 16.45 as well.
Okay. What's the not the applet, but the critical score for 90? I don't have my applet up.
1.645.
Yeah.
1.645?
Yeah.
Okay, cool. Nice.
So which of the following statements is true? Standard deviation squared is an interval estimator of x bar. X bar is a point estimator of sample mean, or the mean. The mean is a point estimate of x bar or the standard deviation is an interval estimator for standard deviation squared?
Let's see here.
I think it's X bar is a point estimator for the mean. I'm pretty sure that's what it is.
Yeah, I think you're right. Because as soon as you have that sample, can't you project it out to the whole population?
Yeah, and in the book it says like it's assuming that X bar is approximately normally distributed about 95% of the time, it will be within 2 standard deviations of the sample mean. So that's, and so it's an interval of it, right? That makes sense. Oh, we're going to point estimators. Yeah.
Okay.
Yeah, no, you're right, because it says if sample mean is unknown, how do we know that X bar is close? And that it is a, yeah, whatever. That's right.
Yeah.
Okay. So Girl Scouts want to construct confidence interval for GMAT score. Oh, Gina. I almost said Girl Scouts. What's wrong with me? She knows the standard deviation is 113. Random sample size 64. The X bar is 526. And then the critical value is 1.96. All right, what is the point estimate for the true GMAT score? 526, right?
Yeah.
How do you get to 5.6?
526.
526.
Yeah.
Oh, so we're just using the point estimate?
Yeah, it says what is the point estimate for the GMAT score is a question, and it's just the X bar.
All right, so what is the margin of error? I got 27.685.
That is what I got as well. Are we rounding to the third decimal place?
Yeah, third decimal, yeah.
So 27.658.
85.
85. Sorry, I'm dyslexic, I guess. Then the lower, 498.315.
Yeah.
Yeah.
The upper is 553.685.
All right.
What would happen to the width of the confidence interval if Gina increased the sample size? It would decrease.
That's correct.
The same thing.
Decrease?
No, it would increase.
Okay. And you said the last one was number 9 was increase or decrease?
9 was decrease.
Okay. Sorry, that's what I thought, but then I thought you said it was the same as this one, so I was freaking out there for a second.
No. I misread the question. The number 10.
Okay.
Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours, and they want a 95% confidence interval within a margin of 50 hours.
50 hours. 50. So now we're just doing the same thing we did last time backwards.
Yeah, what sample size is needed?
Yeah. Sorry. And I set up a spreadsheet for this one.
I didn't set up a spreadsheet for this one either.
We could still use your spreadsheet though, using GoalSeek. Set the margin of error equal to 50 by changing the sample size cell, right?
Yeah, you're right.
Yeah.
Let me take that out. Okay, what if GoalSeek? Wait, let me make sure I have the other things correct though before I try and do this GoalSeek.
Okay.
Critical value at 1.996 and the standard deviation of 400, right?
Yeah.
Okay. Now let's run this GoalSeek. change it to a value of 50.
Goal seek's just a variable or a formula, right?
No, it's actually I can share it with you, share my screen with you guys.
If you don't mind.
Yeah, not at all. Okay. Share screen. Share this. Okay. So here is the spreadsheet that we have here. What you do is you go to data right up here, and then you go to what if analysis. Okay. Let me know when you've found that.
What if?
Oh, yeah. Data and then what if analysis.
But I click on my sample size for the what if, right?
Yeah. Well, after you open up GoalSeek, then you can still manipulate the cells. So I've got this GoalSeek window open. It needs 3 inputs. The first one is the cell that we're going to set, and we're going to set the margin of error to 50. And we're going to do that by changing the sample size cell right here. So we're going to set margin of error to 50 by changing the sample size. I'm going to click OK.
Oh man, too easy. I forgot GoalSeek. I did that like my very first semester in school.
So the set cell is going to be the margin of error. I set it to 50, and by changing the sample size
one. Yeah.
Yeah.
I'm going to stop sharing.
So I got 245.86666. So it would be 246.
I got 245.862.
Yeah, that's what I got. 245.862.
See mine when I did that stuff, it changed it to 49.999. Whatever. But I think either way, 245.8 is going to round it up to 246.
Oh, I'm sorry. I thought we had to do. All right. I'm sorry. I thought we had to do. I didn't know we were doing a whole number. My bad.
Yeah.
So 246.
We're all like, no, that's not right. It doesn't matter. Same number.
Excuse me.
Right.
That's pretty cool. I didn't know that. I'll have to remember that.
Yeah, it's amazing. Saves my life.
Way nice.
All right. The mean salary of actuaries is U equals 100 grand, and the standard deviation is 36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set a hypothesis test with a level significance of alpha equals 0.05, and then you have your hypothesis. Hypotheses. You collect a simple random sample of n equals 36 women's salaries and find that x bar equals 111,000. Use this information for the next 3 questions. So 111,000 is the point estimate. N equals 36.
That's
And deviation
sample
is
size 36.
Standard deviation is 36,730. 36,730.
And we're doing a
95 confidence and 95% confidence interval if we do that.
1.96.
So what is the lower limit of a 95% confidence interval?
I got 99,001.
That's
exactly $2 when I round.
$99,002.
Yeah.
We do round. Okay.
And the upper limit
122,998. Rounded up. We always round up.
999.
Well,
mine's I got 0.4. Oh, but that's 0.5. All right. Yeah.
I got a 0.5.
Yeah, so 9. So 122,999.
Yep. Okay. There are 3 requirements that need to be checked when computing confidence interval for a mean. They are all of the above.
Yeah.
Next, that's all of them.
Yep.
I'll submit it first. And I have to. It's like, are you sure you want to submit? Yes. Okay, last chance. You really want to submit? Yeah.
Yeah, we got 100%. I submitted it.
All right. Golden. Good work, team.
Thanks for that spreadsheet, Spencer. It's a live change. And that goal seek there.
Yeah, that goal seek was super helpful. I will remember to do that from now on because I always hate trying to change things because yeah.
It's amazing. And goal seek can only deal with one variable, but there's another thing in Excel called solver, and you can deal with up to, I don't know, 5 different variables and make it all equal one thing by changing 5 different things at once. Anyway, well, I've got to go, so I'll talk to you guys on Wednesday.
See ya.
See you later.
Bye.
All right, we'll get this going.
Sounds good, man. Have a good one.
You too. Bye.